In this video, we are going to learn about types of systems. So, what is meant by system? A system that processes an input signal and produces an output signal. Okay. Simply, let's take an example. Let it be your mobile phone. Okay. It will take. It will receive calls, right? When we answer, it will produce outputs, right? So this is how the system will be. System is nothing but the device. So it will process an input signal and produces an output signal. Okay. Now let us write the system in terms of function. So y of t, let it be the output signal, and x of t will be the input signal. What is the t means? T will be system or system factor or operator. Okay. So this is the system t. So it is taking x of t as input and producing y of t as output. What is the y of t? Y of t is nothing but t into x of t. Okay. This is how in technically we are writing the system. Okay. Now let us see the types of systems. Now in the first type, it is a linear and non-linear systems. A system is linear if it satisfies superposition principle. The superposition principle is based on additivity and homogeneity. Okay. When these two satisfied, it is a superposition principle. If superposition principle satisfies, then the system is said to be the linear. Okay. So when we see the superposition principle in mathematically, this is as follows. Okay. T of a x1 of t plus b x2 of t, which is equals to, so at x1 of t plus bt x2 of t you need to get. So superposition theorem, let us see in the diagrammatically. So when you get the x1 of t, a x1 of t, b x2 of t, this is the t. So in the output it should like at x1 of t and bt x2 of t. Okay. Or you can write like this also, t a x1 of t plus tb x2 of t. Only this should come. When this is coming, this is known as a superposition principle. What is the additivity means? See, this is additivity. What is the homogeneity? This is the homogeneity, like bt, at's. Okay, this is the homogeneity. Now let us see one example. You will get the idea on this. Here y of t, which is equals to x square of t. Okay. When x of t is passing through system, then we are getting the y of t. Y of t is now x square of t. Suppose if we add a constant to it, like ax of t, when it's passing to the system, then it will producing a square x of t. See, when a x of t is passing through system, it is producing a square x square of t, right, due to the system. So which is not equals to the a x square of t. So what we need to get? We need to get only the thing is, so x square of t, a should remain as it is, not a should come as a square. So this is how the superposition principle will be. So now homogeneity y of t, which is equals to the a x square of t. So ax square of t, which is not equals to the a square x square of t. Okay. See, this is not equals, right? So that's why the homogeneity is missing for this example. So it is not satisfying superposition principle. So that's why the system is non-linear system. I hope you got the idea on this. In order to understand, let us take y of t as 7x of t. Okay. So this is a system. This is x of t. This is a y of t. What is the system t is here 7, right? So now let us pass this signal. Let us check the superposition. So when we pass a x1 of t plus b x2 of t to the system t, then it will be the t of a x1 of t plus b x2 of t. T here is 7, right? So replace with the 7 all things. Now it is like, which is equals to the 7a x1 of t plus 7b x2 of t, right? So hence here this is satisfying. See, this is the same to the superposition principle. Hence this is the linear system. Okay, now let us go for the another type. So let us see the time invariant. So in the time invariant, a system shift in input causes same shift in output. If the shift in input will result the same shift in the output. Okay, like x of t is y of t, then x of t minus t naught which tends to the y t minus t naught. Okay, let us see the example y of t, which is equals to the x t minus 2, shift in input by t naught, like x minus t minus t naught, which is equals to the x t minus 2 t naught. Okay, say for the t minus t naught will coming, right? So output also shift equally, which is known as the time invariant. So when you see the another example, you will get the clear difference how this time variant and invariant will be. Okay, example number 2, y of t which is equals to t into xt. So now let us apply the shifting property x t minus t naught, which is equals to the, here also t, right? T minus t naught, x keep as it is, x of t minus t naught. See here, not only in shifting the time, it is also shifting in the amplitude. What we discuss, if the property which is shift only in terms of time, same shift in terms of our time, it is known as the time invariant. If any changes a part of that, it is known as the time variant. Along with the time, there is a change in the amplitude, right? See, this is the x of t. After applying this, it is becoming t minus t naught of x minus t minus t naught. See, here there is a compromise in amplitude, right? So that's why it is a time variant. So I hope you got the idea on this, like what is meant by time variant and time invariant. If only this thing means it is the time invariant. If any changes a part of this, it is known as the time variant. Okay. Now a causal and non-causal systems. Causal systems output depends only on present and past input, not the future input. Okay. See, causal system only depends on now and past, present and past inputs, not on the future inputs. Okay, what is non-causal system? Depends on future value. So if the system is depending present and past, then it is known as a causal system. If it is depending on the future values also, then it is known as a non-causal system. Okay, now what is the stable and unstable systems? If bounded input gives bounded output, system is stable. Bounded input and bounded output, you can remember in shortcut B-bar rule. Okay, for the bounded input, if it is giving the bounded output, then system is stable. How means? Let us see by the example y of t, which is equals to the 2xt. Let x of t equals to 1, then y of t will be the 2, right? See, for the graph, if we maintain x of t is 1, then y of t will be the 2. See, for the bounded input, see, for the a limited version of input, we are getting the a limited version of output. So for the bounded input, we are getting bounded output. So that's why the signal, it is a stable signal, sorry, stable system. Let us go for the another example. For the y of t, t x of t. Okay. Let us take x of t as in the fixed form 1 1 1. Let the time changes, right? 1 2 3, it will be changing. Then y of t also will change like 1 2 3. So for the fixed input we are getting the non-fixed, like for the bounded input we are not getting the bounded output. See, if we plot the graph for x of t, it will be the 1, but the for y of t, based on the time, the graph is increasing. So for the bounded output we are getting non-bounded output, so that's why it is known as the like non-stable or unstable system. Okay. Now invertible and non-invertible systems. Invertible and non-invertible systems means, first let us go with the invertible. Input can uniquely record from the output. So we can easily recover the input from the output. Like, let us go with the example y of t, which is equals to 2x of t. Then x of t, when we send the x to the other side, like y by t of 2 will be the x of t, right? So input we're recovering from the output. So that's why this is known as the invertible. When we go for the non-invertible, different inputs produce same output. So different inputs produce same output means we can't recover the input from the output. Remember, we can't recover the input from the output. Suppose if the example is y of t x square of t, f x of t, so y of t is x square of t, right? Then x of t will be the under root y of t, right? Suppose x of like y of t will be the 4 means under root 4, which is like plus 2 or minus 2. See, we are getting the multiple input values for the single output value. Okay, output y of t is 4 means then y of t it may be the 2 or minus 2. So we can't recover the input, right? What is the exact input we can't recover from the given output. So that's why it is the non-invertible systems. I hope you got the idea on the types of systems. If you learned anything in this video, please do a like and support by subscribing. Thank you. Thanks for watching this.